Now we want to talk about the law of indices. In the previous video, we learned about the base number, the power, exponent, and index number. So we want to start applying the principle in this case. So in this video, we're going to talk about the first three laws, and then we have supporting examples to help us understand how to apply them. And then we're going to recap some of this content at the end of the video. So let's begin by looking at the first law. We have k raised to power m multiplying k raised to power n. You'll notice that we have same base number. In this case, because the base number are the same, we can now add the indices, and that will be k raised to power m plus n. In the second law, we're saying we have k raised to power m divided by k raised to power n. Remember again, we have the same base number, different indices. We're going to subtract the indices and keep the base number. In the third instance, we have k raised to power m, and there's the brackets, and then raised to power n. So in this instance, we are going to multiply the indices, m multiplied by n, and k raised to power m times n equals to k raised to power mn. So let's begin by looking at the example around the first one. So let's take the first one. K raised to power m, k raised to power n, and we say k equals to m plus n. So our first example will be 2 raised to power 5 multiplied by 2 raised to power 3. In this case, we have the same base number, and that will give us index. In the first case is 5, and in the second case is 3. And you'll guess it right. 2 raised to power 8 is the correct answer. That is how we apply the rule in this case. The second example, we have 4 raised to power 3 multiplied by 4 raised to power 2. You notice the same base number. So we're going to have one base number. Look at the indices. We have 3 plus 2, and that is 4 raised to power 5. And in the third case, we have 7 raised to power 6 multiplied by 7 raised to power 4. Remember again, the same base number. Because of that, we can now add the indices, 6 plus 4. So 6 plus 4 give us 7 to the power of 10. In this case, you notice one thing. When we have the same base number being multiplied, what do we do to the indices? We add the indices. When we multiply, we add the indices. So please don't forget. Let's go to the second example. We have k raised to power m divided by k raised to power n, and that will give us k raised to power m minus n. Remember, in the first case, we have multiplication. We added the indices. In this case, where we have the division, we're going to subtract. And you might wonder, how so? Let's play around with it and you see. Again, I'm going to work with 3 examples here. Our first example will be 6 raised to power 5 divided by 6 raised to power 2. If we apply the second law of indices, we have the same base number, and the first index number is 5 and the second index number is 2. Whenever we have division, we're going to subtract the index. It's a standard rule, and this will give us 6 to the power of 3. Let's quickly prove it. So what this means is like if we are saying 6 raised to power 5 and 6 raised to power 2. So we have 6 multiplied by 6 multiplied by 6. So over 6 times 6. If we divide, see what happens? This 6 cancel out 1, and this also cancel this 6. How many 6 is remaining? 1, 2, 3. Look at our answer. You can see how beautiful the principle of indices is. It simplifies. Instead of writing so many numbers, we just go straight to the point. Let's look at the second example, and we also prove it same way. 10 raised to power 4 divided by 10 raised to power 2. Since we have the same base number, this will be 10 raised to power 4 minus 2. We have to subtract because we are dividing. Don't forget, when we multiply, we add. When we subtract, when we divide, we subtract. So this will give us 10 raised to power 2. We can check again. 10 times 10 times 10 over 10 times 10. By the time this cancel this out, how many 10 do we have left? 2. So you can see the similarity. Now the third example, we have 2 raised to power 8 divided by 2 raised to power 3. You can pause the video if you want to give this a try. So we have the same base number, as you can see, and we subtract the indices because of division. So we have 8 minus 3, and this will be 2 raised to power 5. 8 minus 3 will give us 5, and we can check. 2 multiplied by 2, 3, 4, 5, 6, 7, 8 over 2 times 2 times 2, 2 in 3 places. So by the time we cancel them out, you see what happens? 2 here, and how many 2 is left? 1, 2, 3, 4, 5. 2 raised to power 5. So you can see that this really agrees in this case. Now the third example. If we have k raised to power m in brackets now to the power of n, it's going to become k raised to power m times n and k raised to power mn. So how do we solve this? It's as if we are saying 10 raised to power 3 now again to the power of 2. Instead of writing 10 times raised to power 3 in several places, we can just say 10 raised to power 3 times 2, and this will give us 10 raised to power 6. Another example is a 9 raised to power 4, and we have 3. What would this be? It's going to become 9 raised to power 4 times 3. We multiply the index, and this will give us 9 raised to power 12. And our final example, we have 5 raised to power 3 and everything to the power of 5. To solve this, to remove the bracket, we have 5 raised to power 3 times 5, and this will give us 5 to the power of 15. So at this point, just in this short period of time, we have learned 3 laws of indices. The first law, when we multiply and we have the same base numbers, we add. When we divide the same base number, we subtract the index number. And when there is a bracket, we multiply. Thank you very much for watching. I'll see you in the next video when we discuss the remaining 3 laws of indices.